This is a talk that is based on a lecture that was given during my fellowship with my mentor, Dean Sestari, and slightly modified. And so we're going to be focusing on the topic of diplopia here. So in this part, we're going to discuss what we mean by strabismus and terms such as tropia and phoria, and finally what we mean by a monocular diplopia. So let's first start off with the definition of strabismus, which refers to a situation where the eyes are not aligned with each other. They're not properly pointing the same direction. And we'll get into how we determine that in the coming slides. And of course, when this is happening, the patient will see double, typically at least. So let's take an example from this cartoon. And here we have the two eyes, and we're almost looking from above the patient. Here we have the brain, and these yellow lines would refer to the optic nerves. Okay, so in our example, let's pretend that this person is in front of the patient, in this case, Dr. Sestari. So first let's consider that these are the visual fields of both eyes, the right eye and the left eye when we're looking from above. And here we have the focus, the visual axis from each eye onto the target. And because both eyes are on target, one single image is perceived in the brain in the center. Now let's consider what would happen if there was a strabismus. So in this case, the right eye is still on the target. The left eye now has deviated outward so that the center of its visual axis is not on the target. As a matter of fact, in terms of the left eye would see the target in its nasal visual field off towards the side that the nose is on. And so it will, in some ways, report to the brain that the target is off to the left. And this is why the patient sees double, because one eye is telling the brain that the target is right in front, and the other eye is telling the brain that the target is off to the left. So let's define what a tropia means now. Tropia is a situation where there is an obvious existing deviation between the eyes. And this is a very extreme case, but where they are not in alignment with each other. And using this term tropia, we can now define that if the eyes are deviated inward, we would call that an esotropia here. If the eyes are deviated outward relative to each other, that would be called an exotropia. Here, this would be a hypotropia, where the left eye is too low. And here we have the opposite, a hypertropia, where the left eye would be too high. Here's a patient that presents, and it would seem that the patient has an eye misalignment, yet he has no diplopia. How could that be the case? How could it be that he doesn't see double vision at all? The answer? He has amblyopia. That means that from birth and childhood, this right eye, for example, probably has been misaligned, and the brain has just learned to shut down the second image so that he doesn't experience any double vision because the brain adapted to the situation at a young age. Now, in terms of what diplopia is, it's important to point out that while sometimes, by definition, we're talking about double vision, that in some cases the diplopia can be manifested by just a blurring of vision. How could that be the case? Well, let's consider that if the misalignment between the eyes is very slight, by 1, let's say 2 degrees, then when the person's staring at an object, the separation between the images might not be enough that they're two distinct images. They might just be overlapping on one another some people call this a ghost image, and that's how they're experiencing diplopia. And obviously this can be very tricky for an ophthalmologist. Can be fooled easily because the patient comes in and says that they have blurred vision, and the ophthalmologist checks each eye by itself and finds that the patient's vision is perfectly normal. What the ophthalmologist has not done is test both eyes together, where a state of confusion would be caused when trying to look at the target. So we've defined what atropia is, an obvious misalignment between the eyes. Now we're going to define what we mean by aphoria. And in order to think about that, I'm going to show you a picture that might be a little striking to look at. So just brace yourself. So here's our picture. And what it's meant to show us is that the eyes, both globes, are sitting in the orbit. And here's the way that I would approach explaining what aphoria is. I would ask, what do you think the odds are that the way the eyes were set in the orbits when you were born, that they're in perfect alignment with each other, such that they're both pointing straight ahead? And the odds are probably very low. And yet, our brain is able to overcome maybe the natural tendency for the eyes not to be pointing the same way by bringing the eyes together. And as an analogy, I would have you consider this lady who's driving this carriage with two horses, and ask you the same question. What are the odds if two horses want to go exactly the same way? And obviously the answer is very low. And as long as we have a young, healthy, strong driver in charge, then she will adjust the way that the horses want to go to keep them going the same way. And of course, in our analogy, these two horses represent the eyes, and the lady over here represents the brain. And of course, we can understand that if this lady becomes sick or weak or drinks or becomes tired, that she might lose the ability to manage holding the horses together in alignment with each other, and that a misalignment might develop. And that is what we're talking about when we talk about aphoria, a situation where someone perhaps has two eyes that in their natural state don't point exactly the same way, but the brain with effort is able to align the two eyes so that they are pointing the same way. This will work again when the brain belongs to a young, healthy, sober person. But if there's a situation where a person's been drinking alcohol, if they're sick, or possibly if they're elderly, then they might not be able to hold off the natural misalignment that wants to develop between the eyes. So again, aphoria we would define as a latent deviation. So it's a situation where the eyes want to be misaligned with each other, and we'll see an example of this in a bit, but that they stay in alignment as long as the brain is able to align both eyes together. The last point to consider in this section is what we mean by a monocular diplopia. And so a monocular obviously means that the diplopia is just coming from one eye. How could that be? Well, the image that we perceive from each eye is formed, or is occurs when the light focuses correctly on the retina. And that light has to pass through all the structures of the eye, starting with the cornea, and then the aqueous of the anterior chamber, the lens, the vitreous. All these things have to be perfectly clear in order for the light rays to travel to the back of the eye. However, you can imagine that if, in this case, there's an opacity in the cornea, or a cataract, or unfortunately in this patient's case a tumor, which is blocking the light coming in, that the light rays will not focus perfectly at the back of the eye and the retina, and actually what could happen possibly is that two different images will be produced on the retina, leading to the experience of having a monocular diplopia. It's not a diplopia because of the misalignment between the eyes. It's a diplopia that occurs because somewhere along the visual axis in one eye, it's being disturbed enough so that almost a secondary place of focus occurs.